Today we're going to look at converting improper fractions and mixed numbers. To begin with, let's go over some basic definitions that I will be using throughout the video. First of all, what a proper fraction is. In a proper fraction, the numerator is less than the denominator. All fractions must end up in a proper fraction form in some way or another. So an example would be 6/7. The numerator 6 is less than the denominator 7. This is the proper way or the correct way that a fraction should be written. Another term that we will be using is an improper fraction. In an improper fraction, the numerator is larger than the denominator. You can never leave the final answer in this form. An example of an improper fraction would be 9/8. The numerator is larger than the denominator, so we would not leave it in this form in the final answer. You can kind of think of an improper fraction sort of like the middle rungs on a ladder. If you've got a ladder propped up against a house and you're climbing up to the top of the house or the roof, then your ultimate goal is to get up to the very top of the house. But you can't get there if you don't have the middle rungs in between. So you can sort of think of improper fractions as being those middle rungs. You don't stand on them for very long, but you need them in order to reach your ultimate goal. The last definition that you will be hearing is about a mixed number. A mixed number is exactly what it sounds like. It is a mixture of a whole number and a fraction. This would be the whole number, of course, and here's the fraction. So 2 1/2. Next, we're going to look at some models of improper fractions and mixed numbers. Let's first begin with this rectangle that is divided into 6 parts. So if I were to color in each one of these parts one at a time, and I only want to write the answer in a fractional form, not including any whole numbers whatsoever, then I would have 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, and if I go to another rectangle, I would have 7/6, 8/6, 9/6, 10/6, 11/6, 12/6, and so on. So I'm going to back this back out, and I'm going to leave it right here. So for an improper fraction, the denominator is going to be 6 because even though we have 2 rectangles here, each one of them is divided into 6 equal parts. The denominator would not be 12. If the denominator were 12, then you would be saying that this rectangle is divided into 12 equal parts and this rectangle is divided into 12 equal parts, which they aren't. The denominator tells you how many parts each one of these is divided into. So our denominator is 6. Then, to get the numerator for the improper number, we just simply count how many sixths we have altogether. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, and 7/6. So 7/6 of the 2 rectangles are shaded in. If we look at it as a mixed number, we simply write the answer as a mixed number, meaning a whole number and a fractional part. So you would look and say how much of the rectangles, or I'm sorry, let me rephrase that. Are any whole entire rectangles shaded in? Yes, there are. This whole rectangle right here is shaded in. So one whole rectangle is shaded in plus 1/6 of another rectangle. So my mixed number fraction would be 1 and 1/6. Let's look at another example. This time let's use circles. So on my circles, I am going to shade in this much of the circles. So my denominator is going to be the same for both the mixed number and for the improper fraction. All of these circles are divided into 8 parts. So my denominator is going to be 8 on my improper fraction, and my denominator is going to be 8 on my mixed number. So for the improper fraction, I count how many eighths altogether there are. Here's 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8, 9, 10, 11, 12, 13, 14 eighths is shaded in. As a mixed number, I look to see how many whole circles are shaded in. There is 1 whole circle plus 6/8 of this second circle. So the answer would be 1 and 6/8. Now later on when you are working with these, you would not leave 1 and 6/8 in this form because 6/8 is not simplified. But right now for this lesson, we're not going to worry about simplifying at the moment. Now if I back this out and shade in a slightly different portion, I'm going to add a little bit more to the picture and change it. So now, let me change that to green. We're going to shade in this much. Once again, I have not changed how many parts the circles are divided into, so the denominator is going to be 8 on both the improper fraction and the mixed number. So I'm going to count up my eighths very quickly. I have 8 parts here, 8 parts here. 8 times 2 is 16, 17, 18, 19, 20, 21, 22, 23. So 23 eighths of the circles are shaded. As a mixed number, I'm going to count my whole circles that are shaded in first. So I have 2 whole circles shaded in plus 7/8 of the third circle. So 2 and 7/8 are shaded. If we were to look at this in the opposite way, and what I mean by that is, if I were to give you an improper fraction and I said to draw a model for the improper fraction, then what you would need to first look at is the denominator 4, because that means that you have to have your picture or the model divided into 4 equal parts. So I am going to just do a square. I'm going to divide it into 4 equal parts. So I need to shade in 5 of the 4 parts. In other words, 5 1/4 sections. So here is 1/4, 2/4, 3/4, 4/4, but I have run out of sections. So what that means is I have to draw another square of equal size, and since I'm freehanding it, I'll just kind of do the best I can. And once again, I have to, according to the denominator, divide it into 4 equal parts, and then I can continue. So I had 1/4, 2/4, 3/4, 4/4, and now 5/4. So this is what my model would look like if I was given the improper fraction. And of course, if you look at it as a mixed number, you have 1 whole square shaded in plus 1/4 of another square shaded in. Now you can convert or change improper fractions to mixed numbers and mixed numbers back to improper fractions by drawing all of these models like I have just done and shading in the parts. However, that is way too time consuming. So we're going to look at a very easy way mathematically in which to convert these. So let's first look at how to convert an improper fraction to a mixed or a whole number. In order to do this, you read the fraction as a division problem. Remember, this is a divider bar. So read it from the top down. 19 divided by 3. And I'm going to work it out underneath. 19 divided by 3. 3 goes into 19 6 times. 6 times 3 is 18. Subtract 19 minus 18, you get 1. And we're finished with the problem. Now, I call this reading the answer as a backwards check mark. Normally, the reason I call it a backwards check mark, it just helps you to remember the direction in which you read the answer. Usually when you make a check mark, you start at the small part of it up here in the middle. You go down, then up. Well, on a backwards check mark to read this, we're going to start at the top, go down, and then up. So our answer, the mixed number answer, is found here. 6 and 1/3. So the mixed number for 19/3 is 6 and 1/3. Now, if we look at the other side, how to convert a mixed number to an improper fraction, then there's another little thing that I like to say what this is called. And once again, you're not going to find this in a textbook. This is just a way to remember the direction in which you read the answer. So to begin with, we can get half of the answer immediately. The denominator is going to stay the same. So I'm just going to recopy the denominator. Now, this is what I call the backwards C, meaning the direction that you write the letter C. Normally you start at the top and come around to the bottom. Well, the way we're going to be reading the answers, we're going to start at the bottom, come around to the top to get our answer. So you start with the denominator. You multiply the denominator by the whole number. 3 times 7 is 21. And then we're going to add the 2 to that. 21 plus 2 is 23. And that gives us our numerator. So the backwards C. Both of these methods are a much quicker, faster way to convert either an improper fraction to a mixed number or a mixed number back into an improper fraction. So I hope this video has helped you understand a little bit more about mixed numbers and improper fractions, how you can model them, but also how you can mathematically use an algorithm in which to convert one into the other.